Pardon?
We can have it next Thursday.
Yeah.
Do we have a test? We have a test, don't we?
Let's see. Next Thursday. No, we have a quiz.
What the heck? We
You
don't
just
test
cancel
this
the
yet?
quiz.
Oh, wait a minute. Nope. Actually, we don't have a quiz either.
Yeah.
Next week there are no quizzes or tests for this class.
That's perfect.
The week after, there are 2.
Oh, wait, 2 tests or 2 quizzes?
A quiz and a test.
What the heck, Mr. Davis? This is a long unit.
Yes, this is a very long unit.
Because we've been doing this for like 3 weeks.
Wow.
It'll be 3 weeks.
Wait, have we been
Yeah.
doing this since school?
Since school restarted, yes.
Mr. Davis, we should have a birthday party.
On Thursday.
We can have your half birthday party too.
Yeah.
You can have your half birthday party a week and a half late. Yeah.
That's okay.
All right. So, special parallelograms.
Just ignore it, yes.
Are you wearing your black sweater?
Yeah. What kind of a question is that?
You said you were going to rotate through your
Yeah, so
sweater.
I was like,
So, yes.
It looks kind of speckly.
Dandruff.
Ew! Dandruff? Riley had dandruff on his black shirt and I was making fun of him.
All right. So, today we're going to start special parallelograms.
Special like Johnson, it's everything.
Y'all are so mean.
All right. A rectangle is a parallelogram with 4 right angles. You guys already knew that. That's not news to you. Okay? Since this is a special kind of parallelogram, all the things that are true of parallelograms are true for rectangles. The opposite sides are
Congruent.
and also
Parallel.
parallel. The opposite angles are
Congruent.
congruent. The consecutive angles are
Supplementary.
supplementary. And the diagonals
Or bisect each other.
bisect each other. All those things that are true for a parallelogram are still true for a rectangle. There is one additional property that a rectangle has that an ordinary parallelogram does not, and that is that the diagonals of a rectangle are congruent. Remember, we talked about in an ordinary parallelogram, the diagonals are not congruent. So, well, hang on a second. Let me draw one for you. I'll actually try to draw it so that it's fairly accurate. That's close. So here's one diagonal. I'll do it in red. Here's another diagonal in black. Which one of those 2 diagonals is longer, the red one or the black one?
Black.
The black one is obviously longer because it leans that direction. With a rectangle, does it lean one direction or the other? No. So since it doesn't lean one direction or another, the 2 diagonals are the same length. And further, since the diagonals bisect each other, that means that all 4 of these little pieces are going to be congruent to each other.
Does that mean all 4 triangles? Actually, no, all 4 triangles might be congruent.
No, they won't be congruent, but what kind of triangles will all 4 of those triangles be?
Isosceles.
They're all isosceles triangles, yes. And we're going to make use of that. Okay? The top and the bottom triangles will be congruent, and the left and the right triangles will be congruent. Okay? All right. So, let's do an example problem. We're going to find the measure of each angle and segment in rectangle JAME. I'm only going to give you one angle, and I'm going to give you 2 segments. That's all. That's all you get. It's enough to do this whole problem, though. Let's start with the angles. I'm going to do the angles in blue. All right. So, What do we know that can be helpful here? Yes.
SA is going to be 52 degrees.
Yeah, those are alternate interior angles. Yes, Sammy.
Since rectangles have 90-degree angles, the other one is going to be 90.
The other one.
The other part of E.
Can you
Like,
just
there's
name
the
it?
top E and then there's the bottom E.
Yeah, can you just name it?
AEM.
Okay,
It's going to be 90 minus 52.
which is
38.
38. Good. What else? Yes.
You know that JAS is 38 degrees too?
Yeah, that makes JAS 38 degrees. Those are alternate interior angles. Yes, sir.
EJS is 52
EJS is 52. Yes, how do you know that?
because they're isosceles. The diagonals with isosceles triangles.
Yeah, in a rectangle, the diagonals make isosceles triangles because the diagonals are congruent and they bisect each other. Yes?
Angle AJS is 38
Right? For two different reasons. Can you give me one?
because it's an isosceles triangle,
It's an isosceles triangle.
and because angle AJS is it's complementary to angle EJS.
Yes, these two angles have to add together to be 90. Exactly right. Yes?
Segments ESJ.
Oh, we're doing angles right now.
Oh.
We'll get there in just a second. Yes.
Do we need to find the angle measures of JSE?
All the angles.
Okay. JSE is 76 degrees.
JSE is 76. Excellent. There are two different ways to find that. Can you please tell me which way you did it?
Because it's an isosceles triangle, so that means that, well, I guess all the angles just add up 20.
Okay. You can do, so you added 52 and 52 and subtracted from 180. I submit that there is a better way to do that, but your way is not wrong. Yes?
38 degrees an exterior angle from 52 and 76, so 38 plus 52 that's not correct.
Yeah.
I was thinking
You said some of the words I wanted you to say. Yes?
Exterior angle?
Yeah?
It's the farther two angles in the triangle.
Yeah. What are those called?
Far angle.
Remote interior angle.
Remote.
The remote interior angles. If I use this triangle, 76 is an exterior angle to these two remote interior angles.
Good job, Josh.
Okay, you were kind of on the right track. And using what Savannah said, if I add these two 52 together, 52 plus 52 is 104. This angle is 104. So this angle is 76. This angle is 104. And just doing alternate interior angles to finish up, this is 38. This is 52. All right, now let's start with the segments. Sammy, I told you could start.
Segments JS, SA, and ES are all 17.
Yes, all of these are going to be 17. Marion?
I have a question about the angles.
Okay,
Not the angles, the segments, I mean. I
okay.
know that, for example, for 30, we can know the other side's measure because that's how it works. But I don't understand how we would know the measure of the bottom of the triangles.
Measure of the bottom of the triangles.
Like AM and JE.
Oh, okay. Well, that's where we're going next. So what you have to do in order to find those, you have a thought?
I was gonna answer, but I don't want to.
Oh, no, go ahead.
Do you divide it by square root of 2?
No, because this is not a 45, 45, 90 triangle. Okay? But take a look at this triangle.
Oh,
Look at the big triangles. What kind of a triangle is that?
a bigger triangle. A right
36.
triangle.
It's a big right triangle. And I know that this side is 34, right? Because 17 and 17 is 34, and this side is 30. I'm going to draw it over here for just a second.
Do we use the square root of 3 for right triangles?
No,
No.
we only use that for 30, 60, 90 triangles. And this
Oh.
is not a 30, 60, 90 triangle.
My bad.
How can we find the length of AM?
I don't know.
Yes?
Isn't it a sausage?
Nope.
No.
Yes?
The Pythagorean Theorem?
Pythagorean Theorem? Yes.
Pythagorean Theorem.
Yeah. We've got a right triangle and we've got two sides. We can do the Pythagorean Theorem, and
It's a Pythagorean triple.
it is a Pythagorean triple. Notice that this is 2 times 17, and this is 2 times 15. Do you remember the other part?
2 times 8.
2 times 8. Very nice.
Wow. Good job.
So AM is 16, and JE is also 16.
Good job, Jackson.
So when you're working these problems, the little triangles in a rectangle are isosceles. The big triangles in a rectangle are right triangles. Okay? With our next figure, that's going to be reversed. A rhombus is a parallelogram with all sides congruent. Yes?
Why did they make the word rhombus sound so much like a circle when it's a square?
It sounds
It
round.
doesn't sound like a circle. Rhombus?
Rhombus reminds me of the school bus.
How does rhombus sound like circle?
Round.
It sounds round.
It
just
sounds
sounds
round.
round.
Oh gosh. Your free association is pretty impressive there. So a rhombus is a parallelogram with all sides congruent. Okay, and again, when you were a little kid, you may have called this a diamond. Okay, and it was probably drawn, tilted so that it,
Looks like a kite.
yeah, it looked kind of like a kite. But the correct name is a rhombus.
Who comes up with these names?
Bob, in accounting.
I think I asked it before and you said the same thing.
Probably. I only have so much A material.
So much what material?
A material.
A?
The good stuff. The funny stuff.
Are we sure that's A material?
Wow.
I know some people ran out of their material. Wait, they never had any.
All right. So, a rhombus has all the properties of a parallelogram. So, the opposite sides are congruent. The opposite sides are parallel. The opposite angles are congruent. The consecutive angles are supplementary, and the diagonals bisect each other. All that stuff is still true.
Why is it different?
The difference is that all the sides are congruent, not just the opposite sides.
So it's just a tilted square.
Yes.
Okay.
Now, what happens because of that? Well, unlike a rectangle or an ordinary parallelogram, the diagonals in a rhombus bisect the angles of the rhombus. So notice here, you can kind of see it. This angle, angle QRT, is congruent to angle TRS. I'm sorry? And these two angles over here are congruent to each other, and those must be the same size because the opposite angles are congruent. If you cut them both in halves, the halves should be congruent. Yes?
In a proof, would we have to say that they're congruent?
We don't do a lot of proofs with the special parallelograms. So don't worry about it. Then likewise, over here, these two angles will be congruent to each other. And these two angles will be congruent to each other.
But they're not all congruent.
All four of these are going to be congruent, yes.
I mean, all 8.
Not all 8, no.
Why not?
Because angle QRS is more than 180, and angle RQT is less than 180. So when we cut them in half, they can't be equal to each other. Right? Yes.
So that means that all the triangles aren't isosceles.
The little triangles? Yeah, the little triangles are not isosceles triangles, but look at the big triangles like QTS.
They are.
QTS is an isosceles triangle. And the second thing that's different here is that the diagonals are perpendicular to each other in a rhombus. So that means that not only that angle, but all four of these angles are going to be right angles.
Kind of like the opposite of rectangle.
Yes, and that's the way I think about it. In a rectangle, the big triangles are right triangles. In a rhombus, the little triangles are right triangles. In a rectangle, the little triangles are isosceles. In a rhombus, the big triangles are isosceles. That's how I keep it straight. All right, let's do a problem with a rhombus. So let's start with the segments this time. We did the angles first last time. Let's do the segments first this time. What is?
KA.
Yes. And? What else is 12?
All of them.
All of them. You got to be...
KY, KA, KR, AY. All 12.
All of the
Sides.
sides. All the sides are 12. Yes, ma'am?
KADDYR.
Whoa. We're doing sides.
Oh, sorry.
That's okay. We'll get there in just a second. What other segments do we know here?
We know segment KD.
Is 8, so
DR is 8.
DR is 8. This is still a parallelogram, so the diagonals still bisect each other. Yes.
We do Pythagorean Theorem with 8 and 12.
To find,
80.
yes. Because we know that that's a right angle, we can use the Pythagorean Theorem to find the length of AD. Now I'm going to cut them down to size a little bit. Let's see, that's 6 times 2. And that's 4 times 2, so this is going to be x times 2. Oh, you know, I could have divided by 4. That would have been smarter. Let's do that.
Wouldn't the 8 one be the exact same?
I'm going to write them differently. This is 4 times 3 and 4 times 2. So this is going to be 4 times x. So I'll have x squared plus 2 squared is equal to 3 squared. So x is the square root of 5. So AD is 4 square roots of 5 and dy is also 4 square roots of 5. We've got all the segments now. Let's do the angles. Savannah, you wanted to do several.
Yes. KAD, KYD, and RYD are all 28.
Exactly right. What else do we know? Yes.
All of like the angles in the middle are 90.
Yeah, all the angles where the two diagonals meet are right angles. What about the other angles? Yes?
You can do Pythagorean theorem. Oh wait, not Pythagorean theorem. Can't you just add 28 and 90 and then subtract it from 90?
Yes, but there's a faster way to do that.
It's the one that he said.
No.
Oh.
Yes?
90 minus 28.
Yeah. the two acute angles in a right triangle are always complementary. So we can just do 90 minus 28 gives us 62.
What's the one that we did on the rectangle?
The exterior angle is equal to the sum of the two remote interiors. You could do that here. An exterior angle is 90. It's got to be equal to 62 plus 28. 28 from 90 is 62. So this is 62, this is 62, and this is 62. Yes, ma'am.
Can I go to the restroom, please?
You may. All right, last but not least, a square. It's a parallelogram with 4 right angles and all congruent sides. That means that a square is a parallelogram and a rectangle and a rhombus. It's all of those things rolled into one. It is the most specialized parallelogram. So it has all the properties of a rectangle, a rhombus, and a parallelogram. No new properties need to be added. It just has all of those. Okay? It is, for any of you who were comic fans or saw the movie, Shazam. You know what I'm talking about. So Shazam is supposedly the embodiment of several different characters. Same sort of thing here. All right. So, remember how we said in a rectangle the little triangles were isosceles and the big triangles were right triangles? And in a rhombus it was the opposite way? In a square, the little triangles are isosceles right triangles. They're both. And the big triangles are isosceles right triangles. Basically, every triangle in this picture is an isosceles right triangle. Okay, which makes it really easy. I don't have to give you very much at all. I'm giving you the length of this one side. We're going to go through this in a big hurry. All of these sides then are 18. And for the angles, I know that all the angles in the middle are right angles. And since these are all isosceles right triangles, they're 45, 45, 90 triangles every single time. Knowing that then, how can I find these little pieces of diagonal? Yes?
Divide 18 by the square root of 2.
Yeah. We divide 18 by the square root of 2. Have you guys gotten to the place where you don't write times square root of 2 over the square root of 2 and just go straight to the answer on this?
No.
Well, let's look at what happens and let's see if we can get you to the place that you do.
We just divided 18 by 2.
Yeah, divide that by 2 and then multiply by the square root of 2. So all of these pieces are 9 square roots of 2. Yeah, the squares don't take any time at all. All right. Let's quiz.
So the quiz, we're not proving parallelograms. It's like you give us parallelogram.
And I ask you stuff about it.
Uh-oh. I don't remember these ones. I don't remember.
You have to fill out the
Okay.
Pardon? I'm sorry. We need everything that you write on that sheet. Okay?